Welcome to the nursery at the National Conservation Commission's headquarters in Barbados. Our goal working with the NCC this summer was to help create a more sustainable potting soil mix, economically, environmentally, and socially. Their current potting soil mix poses the following unfavorable conditions: heavy weed load, poor infiltration, and high soil compaction, all leading to more work for the employees. We wanted to swap imported materials for more locally available and sustainable ones.
Let's get to work. First things first is to decrease the heavy weed load of the potting soil at the nursery, as seen in this clip. To achieve this, we chose a technique called solarization. Solarization involves the heating of the soil to a high enough temperature to inhibit weed seeds and pathogens. It's achieved simply by covering a pile of soil with clear plastic and leaving it to sit in the direct sun for 2 or more weeks, making it a sustainable, eco-friendly way to decrease the weed load of soils. In our preliminary solarization trial, we wanted to find the source of weeds and how long it would take to kill any weed seeds. We set up piles containing manure and topsoil covered with black plastic bags and left them to sit to ideally heat up over the next week. Here we used chicken, sheep, and horse manure. It turns out that the black plastic actually cooled the piles down instead of heating them up. So although it didn't work here, we learned that solarization was better performed under clear plastic and in direct sunlight.
In the next phase, we began our solarization at the NCC nursery with the necessary adjustments. We used clear plastic bags instead of black to create a greenhouse heat trapping effect, and we used only horse manure to limit confounding variables. The piles we created included one higher topsoil to manure ratio of 20 to 80 and a lower one of 10 to 90. We also solarized the existing topsoil and manure mix used by the NCC to monitor its temperature changes, and another mix with bagasse to see its effect on soil temperature. After letting the piles sit for 2 weeks, the piles heated up and the temperatures increased. The pile with topsoil and bagasse heated up the most, showing that bagasse has the potential to make solarization more efficient.
Finally, we were ready to create our potting mixtures. We used coconut fiber, perlite, and peat moss alongside with bagasse, manure, and topsoil. 6 different potting mixtures were created. In all mixes, perlite was kept constant at a half of a part. 3 of our trials incorporated coconut fiber and the other 3 using peat moss, with the intention of comparing these 2 materials as amendments. Similarly, 3 of our mixtures contained the 80 to 20 topsoil to manure ratio, which were considered high nutrients, while the other 3 contained 90 to 10 mixtures, which were considered low nutrients. We included the solarized bagasse and topsoil mixture into 2 of the trials to see how it affected the soil.
Our army of potting soils.
The next step was transplanting the rooted cuttings. We chose to pot bougainvillea, poinsettia, lantana sage, and baby sunrose as they were readily available at the NCC and have varied nutrient and drainage requirements. We potted 3 of each plant for each soil mixture. We ended up potting 72 plants in one day. Finally, we filled 3 pots with the NCC's current soil mix as a control to compare weed growth with our potting soil mixtures. The next 4 weeks were spent counting weeds, recording qualitative observations, and performing soil tests. Infiltration tests were done by timing how long it took a set amount of water to fully enter the soil. The infiltration data we compiled showed that, on average, the potting mixes we created infiltrated at least 7 times faster than the control. One time, the control mix took 4,506 seconds to fully drain. So, if you thought that a watch pot never boils, you've obviously never watched water infiltrate into poor soil.
We also performed a compaction test by measuring week by week how much the soil had receded from its initial height. Our data showed that the control soil ended up compacting much less than the potting soils that we mixed, showing that compaction is not correlated with infiltration rate as we initially hypothesized. Also, our potting mixes grew fewer weeds than the control pots did. This means that solarization works.
While this study did not determine one best potting soil mix overall, the potting soil designed for low nutrient and low drainage held the highest ranking for plant vigor, has the lowest cost for the NCC, and replaces peat moss with locally sourced coconut fiber. Because there is no single best mix, the NCC Nursery can experiment in utilizing these materials and practices in the ongoing process of upgrading their potting mix in whichever ways they best see fit.
We would like to thank the National Conservation Commission for this incredible opportunity, especially our amazing mentor, Carla Stoughton.
Also, the staff at the nursery who helped us out along the way. Shout out to Linda.
And thank you to Dr. Caroline Begg for supervising us in our project and for her expertise in plant and soil science.